Hi grade 11s. Right, this video is on the second topic within financial maths, and this is when stuff starts to get a little bit more interesting. So we're going to look at interest rates and what happens in reality. So interest rates are normally quoted as a percentage per annum. Now that's true in real life. If you go to a bank or if you go to make an investment or take out a loan, generally they will quote you an interest per annum, which is per year. But the reality is that doesn't mean that at the end of the year you get 12%. That's not how the real world generally works. Interest is generally added more frequently than once a year. So interest can be added, or the better way to say this mathematically is we say interest is compounded. Now it could be compounded every month. It could be compounded twice a year. That would be every 6 months. Now that word for that is semi-annually. Or it could be compounded quarterly. Now I'm sure you would guess that quarterly means 4 times per year. Now the reality is you could add interest whenever you want. You could add interest every second, every millisecond. If you have an investment, the more often you add interest, the better. Because don't forget that compound interest always calculates interest on the current amount. So the more often you're adding interest, then the next calculation is on a higher amount. So we're going to have a look at how that works out. So let's just look at an example here. This first example says the bank gives me an interest rate of 12% and P.A. stands for per annum, but it's compounded semi-annually. What does that mean? That means that yes, you're going to get 12%, but in 2 chunks because semi-annually. So what interest would you get after 6 months? You would get 6% interest after 6 months, and at the end of the year you'd get another 6%. Now, why would this make a difference? Why don't you just get 12%? I mean, 6 plus 6 is 12. Don't forget that this is compound interest. So at the end of 6 months, you'll get 6% of your current balance. But then at the end of another 6 months, you'll get 6% of your new current balance. And so because that balance has gone up with that 6-month interest, that second 6% will actually be a higher amount, simply because the amount went up by that interest at 6 months. So we're going to look at an example because it's quite hard to talk about something and imagine it. So we're going to look at an example in a moment which shows us exactly that. But before we do, we just need to quickly discuss 2 bits of terminology here. There's something called an effective interest rate, and there's something called a nominal interest rate. Now, an effective interest rate is where the per annum matches when you compound. So this is when you have matching time periods. So what I mean is, if I give you an interest rate per annum and I tell you it's compounded annually, then that's an effective interest rate because they match. So for example, per annum compounded annually. Now that's pretty much the only effective interest rate we work with, because all interest rates in the world are compounded, are stated per annum. But it doesn't have to be per annum. You could say per month, compounded monthly. Now technically that's what's called an effective interest rate, because your compounding period, as in your monthly compounding, matches your quoted rate per month, compounded monthly. So there's no problem. Generally, you probably will never see that. And we will always talk about per annum compounded annually as your effective interest rate. So it just means your time periods match. So what's a nominal interest rate? A nominal interest rate is when your time periods don't match. So for example, if you get an interest per annum, but then it's not compounded annually. So it's compounded monthly, or compounded semi-annually, or compounded quarterly. So your quoted interest rate does not match when you get that interest. Now it doesn't really matter, but they like to use those words. We're going to do converting between these two in a couple of lessons time, and so we just have to know what they're talking about when they use these terminologies. So we'll come back to effective interest rates and nominal interest rates, those words, when we need them. Right, so let's look at an example which will hopefully kind of iron out things for us. Example number 1 says case 1. 100 Rand is invested in a savings account. Calculate the total amount in the savings account at the end of 1 year if the interest rate is 12% per annum compounded annually. Now the moment I see that, just to practice these words, this is clearly an effective interest rate, simply because it's quoted as per annum and it's compounded annually, and so they match. Now this seems pretty much what we've been doing from grade 8. 100 Rand, 12% per annum compounded annually. I can just use my formula. So it's 100 Rand, 12% interest for 1 year. And if I pick up my calculator, I get 112 Rand, which makes sense because 12% of 100 Rand is 12 Rand. So at the end of the first year, I'd have 112 Rand. Now let's look at the second case. The second case is exactly the same numbers. So 100 Rand is invested in a savings account, but this time the interest is 12% per annum compounded monthly. So this is now a nominal interest rate, just to practice those words, simply because the interest rate is compounded monthly, but it's given to you as per annum. So my first question, if you have 12% per annum but compounded every month, that means divided up into monthly installments of interest, if you like, what is the percentage rate that you would get every month? Now, you get 12% over the whole year, but divided into 12 kind of installments. So that means every month you're going to get 1% of your interest. So we're going to complete the table below. So the first question says, what would you have at the end of 1 month? Well, I would have 100 Rand, and then I would have an extra 1% of 100 Rand, which would give me 101 Rand at the end of the first month. Now there's a very nifty way to do this on your calculator, which I'll show you in a second. So what do you have in the second month? Now don't forget this is compound interest. So you have 101 Rand because you started with that, but now I'm going to add 1%, and not of 100 Rand, of 101 Rand. Now that means that you're going to get more interest in that month, simply because you have a higher current amount than you did in the first month. So because your current amount is now 101 Rand, look at what your interest calculation is. Your interest calculation was 1% of 100, it's now 1% of 101, which is why this amount is going to be slightly more. Now how much more? Well, it's 102 Rand and 1 cent. So instead of earning 1 Rand interest, you earned 1 Rand and 1 cent. Now that seems insignificant until you're talking about millions and millions of rands here. Now the nifty thing about your calculator and how you can get your calculator to do this for you is this 102 Rand and 1 cent will now be on your screen on your calculator. So that if I push answer, it uses that answer. So now I want to say, I want to take that answer and I want to add on 1% of that answer. So if you put that in your calculator, you should really try this. It's really nifty. So if you go answer plus 1% times answer, you should get 103 Rand this time. So it's 103 Rand, and if I put in all the cents, it's 0.0301. Now what's really nifty is that because you use the answer key, your calculator now knows that what you wanted to do is to take that answer, add 1% of that answer, and keep on doing that every month. So every month it's going to be using the new current amount. So instead of doing that calculation every time, because you use the answer key, if you just push equals on your calculator will automatically do that exact same calculation for you. It'll say answer plus 1% of answer. So if I just keep on pushing equals, I can get all of these amounts without doing any work at all. It only works though if you use the answer key, because then it knows that it wants you to keep on doing that with the answer. So at the end of 7 months, what it's done is it's taken 106 Rand and 15 cents and it's added 1% of 106 Rand and 15 cents. And so if I keep on going, really is quite a nifty technique on your calculator. You'll notice that every single time my amount is slightly bigger than an extra Rand. So instead of just going up by 1 Rand, which is 1% of 100, it's going up by slightly more every time. Now again, it doesn't seem like much until you talk about millions and millions of rands. So eventually, at the end of 12 months, if I round it off to 2 decimal places, because finally I've got to my answer, I've actually got 112 Rand and 68 cents. So let me just quickly explain there what I did again. This question was different to case 1 because it was 12% per annum, but it was divided up into monthly installments of interest. So basically you were getting 1% each month. Now that's 12% over the whole year, except every month, because I'm adding on interest, my current balance in my account goes up a little. So when I work out 1%, I'm now working out 1% of a bigger amount each time. And so what I've done in every single one of these months, I've taken the current balance and added 1% of the current balance. Okay, now let's compare that. Compare the amount we had in case 1. Now, if I remember correctly, it was 112 Rand in case 1, and in case 2, 112 Rand and 68 cents. Which option landed up with more money? Well, clearly case 2, a whopping 68 cents extra. Again, don't let that fool you. The moment you're talking about millions of rands, that's a lot of money. Why did that option end up with more money in the account at the end of each year? At the end of the year. Now, that's because the power of compound interest. Because at the end of each month, you are getting interest on the current balance. And so every month you're getting interest on interest as well as the original amount. Whereas the 12% once at the end of the year, that was just a once of 12%. There was no interest on interest. So the more often you add interest, even though the numbers look the same, 12% both times, you actually earn more. So I'm just going to write that out. So what I've done there is just written out what I've just said. In case 1, you get a once of interest of 12%, and in case 2, you get interest on the current balance every month, and that current balance is increasing every month, and so you get interest on interest and more money in the end. So ultimately, the more often you compound your interest, the better. Okay, let's look at the next question. If you were offered 10% per annum compounded quarterly, or 10% compounded every 6 months, which option will earn you more money? So let's have a look at this. They have given you exactly the same interest rate, except here compounded quarterly means 4 times a year, and compounded every 6 months would mean twice a year. Now, which one's better? It's always better to get interest more often, because then you get interest on interest. Ultimately, you're still going to get 10% in a way, but you're going to get 10% in 4 pieces. So that would be 2.5% each time. Or you could get 5% twice. But 2.5% 4 times is far better, because you will be getting interest on interest 4 times. So the more often you compound, the better. So 10% per annum compounded quarterly. Now, something really important to notice here is, I know it says the same percentage. It says 10% compounded quarterly or 10% every 6 months. And so I know those numbers say the same, but effectively you're getting a different interest rate. If you look at the overall effect in the end, you're not getting the same amount out. In the previous question, 112 Rand and 68 cents versus 112 Rand, that's not the same effect in the end. So just because the numbers look the same doesn't mean you get the same final amount. Fourth question here says 12% per annum compounded annually and 12% per annum compounded monthly. So these are the interest rates to be used in the first example. Clearly do not yield the same amount. Now they don't. Case 1, which was compounded annually, got 112 Rand, and case 2 got you 112 Rand and 68 cents. So even though the interest rates look the same, they do not yield the same amount, so they don't have the same effect. Now it says, determine the interest rate per annum compounded annually that would have given you the same yield as case 2. So what they're saying is, how do I get the same thing out? How do I get 112 Rand and 68 cents? So how does A be 112 Rand and 68 cents if I still started with a P of 100 Rand, but my interest rate was once in the year? So just once. So none of this compounded monthly, just once. Well, we can use our A equals P1 plus I in formula to find that. So 112 Rand 68 is what I want out, starting with 100 Rand if I got interest once a year. So if I divided by 100, I get 1,268, I think. Now that would equal 1 plus I. So if I subtract 1 on both sides, I get 0,1268. Oh, sorry, that was what I did wrong. I knew I'd done something wrong. Sorry, I get 1,1268 equals I. Sorry, so just notice I made a bit of a typo there in that line there. I forgot this 1 here. That makes a lot more sense. And of course I need to write this as a percentage, so when I multiply I get 12,68%. Now you'll notice that looks strangely connected to that, and it is connected, because on 100 Rand, if you earned 12 Rand 68 cents interest, your interest rate would be 12,68%. Now this is a really important example, because this shows you that 12% compounded annually is not the same effect as 12% compounded monthly. They look the same, but they don't give you the same effect. So what would have the same effect? 12,68% per annum compounded annually has the same effect as 12% per annum compounded monthly. So we would say that this is the effective interest rate, because it's per annum compounded annually, that gives you the same outcome as the nominal interest rate of 12% per annum compounded monthly. So ultimately, if you went into a bank and they offered you 12.68% per annum compounded annually, or they offered you 12% per annum compounded monthly, and they asked you which one you wanted, they're actually the same thing. They don't seem like the same thing, but when you calculate your final amount, you'd actually land up with the same amount in your account. So just to say that again, we're going to touch on this in the next lesson, so not in this one, but it's just a nice introduction. This 12.68% is the effective interest rate that has the same effect on your money as 12% per annum compounded monthly. So they are the same thing. Okay, so let's do a couple of examples now, because now that we've kind of delved into this idea of nominal interest rate and the idea that you can get interest more often than once a year, how does that now affect our calculations and our formulas? Right, let's look at example 2. Example 2 says 1,000 Rand is invested into a savings account. Interest is compounded monthly at 15% per annum. So that's a nominal interest rate because it's per annum, but it's compounded monthly, so they don't match, which is not a problem. So the first question there says, what percentage interest is given each month? Now, 15% is what you get over the whole year, but this is compounded monthly, so you're going to divide it into 12 installments. Now, I don't ever write like that. I write 15% as a decimal, but it doesn't really matter. So in my formulas, I would use 0,15 because I'm just used to that. You're welcome to use the percentage sign. but basically 15% of the whole year, but it's dividing itself up into 12 installments. So B says, how much money will you have in the account after 6 months? Well, this is where I need my formula. My formula is A equals P, 1 plus I to the N. If I write myself a quick shopping list, my original principal amount is 1,000 Rand. How much money I have? My interest rate is not 15%, because you're not getting 15% ever. You're getting 15% divided into 12 monthly chunks. So what interest do you get when you get interest is 15% divided by 12. Now this is where N doesn't stand for number of years. N stands for how many times would you have gotten that interest. Now if this was in 6 months, this interest you would have gotten 6 times, because this is a monthly interest rate. So it's an important mind shift to realize that N actually never stood for number of years. It's just that in grade 8, 9 and 10 we only ever did annual interest. So if I substitute into my formula and pick up my calculator, 15% divided by 12 for 6 months. Now I get 1,077 Rand and 38 cents if I round off. Next question says, how much money would it have in the account after 12 months? Okay, now there's 2 options here, because either I can go back to my 1,000 Rand and just change my 6 to 12 and do the same calculation, or I can start with my 1,077 Rand and 38 cents and just do it for an extra 6 months. So I'm just going to show you both of those. Chances are we'll land up with slightly different senses, a different rounding, simply because this 1,077 Rand and 38 cents was a rounded off amount. So either you can take that amount from 6 months and add on 6 months more interest, or you could take 1,000 Rand from the start and add on 15% compounded monthly, but for 12 months. So let's see what we get. So if I do the 1,000 Rand, I get 1,250 Rand and 58 cents. Okay, now let me just correct that, because I clearly pushed something incorrectly. I got 1160.75. Now I know I did something incorrectly because I did the other calculation and it was 1160, and so I can't possibly be that far off. And actually in the other calculation I happen to get exactly the same rounding. So sometimes there'll be a cent or two difference because this 1,077 Rand was rounded, but I would mark both correct, so it doesn't matter. So it's really important in looking at this, these new types of questions, to remember that your interest rate needs to be, what interest do I get every time I get interest? So you need to divide it into its portions, and then N stands for how many times that I get that interest. Okay, now question D, something we're going to be exploring in the next lesson, is this idea of the effective annual interest rate. So what do they mean when they say determine the effective annual interest rate? They mean what interest rate would give you the same outcome. So what interest rate per annum compounded annually? So that makes it effective because they match. What interest rate per annum compounded annually will give you the same outcome? Okay, well the question is, what was this outcome? This outcome was 1,160 Rand and 75 cents. So how do I have that same A value if I start with 1,000 Rand? What interest rate would I need if I only got interest once in the year? Because it was an effective interest rate. It wasn't compounded, it was just once. So what we can do is we can use our formula. 1160.75 equals 1,000, 1 plus interest rate, once. So I would divide by 1,000 on both sides. So I get 1,16075 equals 1 plus I. So I'd minus 1 on both sides. And so I get 0,16075. And then when you multiply by 100, you get 16,075, which is 0.08%. Now notice that's quite a lot bigger than 15%. Now it has to be bigger than 15%, because your 15%, if you divide it into 12 pieces, that 15% you'll be getting interest on interest every single time. So you're automatically earning more and more and more money. So if you're only going to get interest once in the year, it has to make up for the fact that it loses out on all that interest on interest. So don't worry if you're not 100% happy with this idea of effective interest rate. Our next lesson is solely going to deal with converting between these two and understanding why they have the same effect. So we will revisit this concept. Okay, so let's look at some more playing around with using these interest rates. Suppose you invest 15,000 Rand in a bank, earning 12% per annum. Okay, calculate the value of the investment after 5 years if it's compounded annually. Now that's an effective interest rate, so I'm going to take my 15,000 Rand and I'm going to add interest at 12%, which I prefer to write as a fraction, for 5 years. It's not divided into certain installments because it was compounded annually. So you were getting that 12% once off every year. So I got 26,435 Rand and 13 cents. What happens if interest is compounded semi-annually? Now semi-annually means twice a year. Now if it's the same interest rate, which it is, I would assume that I would going to be landing up with more money at the end, because my principal amount is still 15,000. My interest rate is 12%, but it's 12% divided into 2 equal installments. And so I'm going to be getting basically 6% each time. So I'm going to be getting interest on interest. Now just be careful with N. N isn't number of years. You can't say 5 years, because N is how many times did you get that interest. Now you got that interest for 5 years, but twice a year. So that is 10 sets of interest you'll get. Now you're not getting 10 sets of interest of 12%. You're getting 10 sets of interest of the 6%. So if I go and substitute into my formula, it's 15,000 Rand. When I get interest, it's 12% divided by 2, which is actually 6%, but I'm going to get interest 10 times. So as predicted, that gives me 26,862 Rand and 72 cents. So, 430 odd Rand extra, which again, when you're dealing with millions of Rands, that makes a huge difference. Right, let's look at C. What happens if interest was compounded quarterly? So same idea. What happens to my 15,000 Rand, except my interest rate isn't 12%, that's 12% per year. Quarterly means 4 times per year. So I'm going to take that 12% and I'm going to divide it into 4 equal installments. So basically you'll be getting 3% 4 times, but every time you're going to be getting interest on interest. So every time you calculate the interest, you will be getting even more money. Now again, you can't say 5 years because it's 5 years but 4 times per year. So you're actually getting interest 20 times. So I'm probably going to get an even bigger amount than the compounded semi-annually. In fact, I definitely should get a bigger amount. So 12% compounded quarterly, 20 sets of interest. So I land up getting 27,091 Rand and 67 cents. So again, slightly bigger. And the reality is if you compounded monthly, you'd get an even bigger amount. If you compounded every day, you'd get an even bigger amount. So I'm hoping you're getting used to this idea of the interest rate being divided into portions and N standing for how many times you got interest and not how many years. Okay, let's look at a last example. Example 4 says you invest 10,000 Rand and after 5 years it doubles in value. What interest rate did your investment earn if it was compounded monthly? So it doubled in value to 20,000 Rand. I started with an original investment of 10,000 Rand. My interest rate, I don't know, so I'm going to call it I. But just be careful, it was compounded monthly. So whatever interest rate this was, you would have to divide it into 12 equal installments. How many times did you get interest? Well, it was 5 years, but 12 times each year because it was monthly. So actually 60 sets of interest. So this is quite a difficult one. I can't just write I there because the interest rate is always quoted as per annum. So what interest did you get per annum but you would have divided it into 12 equal installments. So it's now 20,000 Rand is my A value, 10,000 Rand is my P, my interest is I, divided into 12 equal installments, and you would have got interest 60 times. So I would divide by 10,000 on both sides, which gives you 2. And now it comes back to this whole idea of getting rid of an exponent of 60. So I would 60th root both sides, as weird as that sounds. So I want a 60th root, because then my exponents cancel, and I'd get 1 plus I over 12. Now I probably wouldn't write this in an exam. I would just do it on my calculator, simply because otherwise I have to write all these decimals. But I get 1,011,619 blah blah. Now I would subtract 1 on both sides, and then I still need to multiply by 12, so I'm running out a bit of space here, but I get 619 equals I over 12. So when I multiply by 12, I get 0,1394. So let me just move along here. I get 0,13943. Now that seems like a very weird interest rate, and the reason why it's weird is you need to times by 100 to get a percent. So don't get freaked out when you see such a weird answer. So if I times by 100 and then round off to 2 decimal places, careful, don't round off too early, because your decimals shift when you multiply by 100. So I actually get 13.94%. Okay, now let's do exactly the same concept, except let's pretend we were compounding quarterly. So again, my final amount is 20,000 Rand. This is why I found my little shopping list really useful, because it just allows me to pause and think. So my interest rate is I, but now I'm dividing into 4 equal installments. Now it said 5 years, but it's 5 years of getting interest 4 times a year, so that's 20. So it's exactly the same calculation, really. Now I'm expecting a higher interest rate, I think, because this interest rate is going to be happening less frequently, which means I need to make up for the interest on interest I'm losing. So if I divide by 10,000, I get 2, and now I get 1 plus I over 4, it's about 20. So I 20th root both sides, and I'm starting to get lazy, so I stop writing these, which is a bit naughty. So I get 1,03526 equals 1 plus I over 4. And again, I start getting really lazy, so I minus 1, I multiply by 4, and then I multiply by 100, and in an exam I would just go straight to my answer of 14,11%. So just to explain to you what I did there, since I haven't written it down, I subtracted 1 on both sides, so I got 0,035, then I multiplied by 4, and then I times by 100. And as predicted, I got a higher percentage than compounded monthly, which does make sense. Okay, finally, let's try one last one, which is compounded semi-annually. So semi-annually, don't forget, means twice a year. So exactly the same A value, we want out to double, so it's 20,000 Rand. From 10,000 Rand, my interest rate is I don't know, but it's divided into 2 equal chunks, and it's 5 years, but twice a year, which is 10. So it's exactly the same calculation, and again I'm expecting an even bigger amount. So 1 plus I over 2 to the power of 10. I divide by 10 on both sides. I would then do the 10th root of 2. So I get 1,07177 equals 1 plus I over 2. And this is when I start to get lazy, so I minus 1 on both sides. Then I multiply by 2. And then to get a percentage, I multiply by 100. So I'll just say that again. I minused 1 on both sides. I then multiplied by 2 and multiplied by 100 to get a percentage. And so now that's an even bigger amount, because if I'm only getting interest twice a year, I have to make up on all the interest on interest I've lost out compared to compounded quarterly. Okay, so this is the whole point of grade 11, this idea that an interest rate can be compounded more often than once a year. So don't worry at all if you find this a little bit unsettling, because this is the whole new concept. After this, then we start practicing this concept a lot, and it starts to become a little bit easier. So basic takeaway from this video is that interest can be added more than once in a year. Interest is quoted as per annum, but then you can divide it into like installments throughout the year. So your I can be divided by how many chunks you want to divide it into. But then it means that N has to stand for how many times do you get that interest rate. Okay, well done guys, that was quite a lot of work.